Hey everyone, welcome back to my channel. Today, we're diving into a topic of utmost importance, the antibiotic disaster. It's a crisis that might not be getting the attention it deserves, but its implications are immense. We'll be discussing the evolution of bacteria's resistance to antibiotics, how they create superbacteria, and the dangers this poses. If you're ready to learn about a pressing global issue, hit that like button and let's get started. 1. Bacteria's evolutionary battle. We all know that antibiotics have been a game changer in modern medicine, saving countless lives. However, their overuse and misuse have given rise to a major concern: bacteria evolving resistance. In this segment, we'll explore how this happens. Bacteria have an astonishing ability to adapt, and when exposed to antibiotics, those that have a natural resistance survive and reproduce. Over time, this leads to the development of antibiotic-resistant strains, a phenomenon we call superbacteria. 2. The immunity spread. Have you ever wondered how bacteria can spread their antibiotic resistance genes? It's like a survival strategy passed down the bacterial generations. We'll take a closer look at the mechanisms bacteria employ to share their immunity traits, allowing antibiotic resistance genes to move between different species of bacteria, even those that don't usually share genes. This horizontal gene transfer accelerates the spread of resistance, making the issue even more challenging. 3. Unveiling the antibiotic disaster. Now, let's address the big question: what is the antibiotic disaster, and how dangerous is it? This term refers to the escalating global problem of antibiotic resistance, where once treatable bacterial infections are becoming difficult, if not impossible, to treat. Imagine a world where common infections, surgeries, and even cancer treatments could become life-threatening due to bacterial infections that can't be controlled by antibiotics. It's not just a healthcare concern, it has economic, social, and public health ramifications. Segment 4. The gravest dangers. In this segment, we'll discuss the real dangers posed by the antibiotic disaster. We'll explore cases where antibiotic-resistant infections have led to prolonged hospital stays, higher treatment costs, and sadly, even fatalities. We'll also touch on the economic burden of this crisis, as well as its impact on food production and agriculture due to the use of antibiotics in livestock. It's a multifaceted challenge that requires global attention. Segment 5. Solutions and hope. But don't lose hope just yet. There are actions we can take to mitigate the antibiotic disaster. From responsible antibiotic usage in healthcare settings to improving hygiene practices and developing innovative treatments, there are ways we can slow down the emergence of antibiotic-resistant bacteria. Researchers, healthcare professionals, policymakers, and individuals alike have crucial roles to play in finding solutions to this crisis. Conclusion, and there you have it, folks, a deep dive into the antibiotic disaster. It's an issue that requires collective effort, awareness, and responsible actions to prevent a future where antibiotics lose their effectiveness. Let's keep this conversation going. If you found this video informative, don't forget to subscribe, hit that notification bell, and share it with your friends. Together, we can make a difference. Thanks for tuning into my channel, and I'll catch you in the next video.
Every day, we race against a threat we can't see. Bacteria and fungi are everywhere in our environment. They're on our hands, on our new puppy's fur, and on the meal we're about to cook. They move as we move, constantly adapting to ensure survival. We figure out ways to stop infections before they start, like vaccines and sanitation, and develop new ways to treat them, like new antibiotics. But germs are always evolving, and they can develop new defenses against antibiotics. Keeping up can feel like swimming against a current. When we make our drugs more powerful, the success is only temporary. Bacterial and fungal illnesses grow harder and harder to treat, sometimes becoming deadly. Whenever we use antibiotics, only some germs will die. The most resistant can survive and spread. These germs then adapt in multiple, clever ways, occasionally combining several types of defense, modifying or destroying the drug when they come in contact with it, disguising themselves so the drug doesn't recognize them as a threat, or passing information to other germs through gene transfer. When germs share and combine defense strategies, they adapt and some can become completely untreatable with existing antibiotics. So, researchers create new drugs, working harder than ever to treat the same infections. The new antibiotics might save lives, but we can't slow down to catch our breath. Every day we can stop the spread of germs and prevent infections to keep people safe. That's why infection prevention is so important. If you prevent the infection, you don't need the antibiotic. And when antibiotics are needed, improving how we use these drugs in humans and animals will help in the fight against antibiotic resistance. Unnecessary or improper antibiotic use can harm humans and animals, and can also speed up the development of antibiotic resistance. By improving how we use and prescribe antibiotics, and by responding at the first sign of resistance, we can help antibiotics stay powerful for when they're truly needed. Combating antibiotic resistance requires ongoing commitment if we want to stay ahead. CDC is leading the public health response in the US, but the world needs an aggressive and coordinated response to combat antibiotic resistance globally. Germs will continue adapting, infections could become even more deadly, and antibiotics could lose more of their power. But through constant effort, we can save lives and preserve antibiotics for future generations. Let's stop germs from winning this race.
More and more bacteria were becoming resistant, spreading across the globe.
Very soon, we will not have enough antibiotics to treat infections.
This is a major public health problem that needs to be solved.
We need to assist each other.
We really need to do more. At CDC, we work a lot with our partners internationally to detect and respond to threats that occur in healthcare, like antibiotic resistance. One of the ways to make a difference is through using existing technology to help us think about problems differently. One of the ways we are doing this is through an app called Acumen that we are piloting in Colombia.
With the Acumen application, you have the guidelines of all the antibiotic use in the hospital and the guidelines of infection prevention and control, the contact precautions, airborne precautions, all the isolations, and the hand hygiene too.
For the patients, the best benefit of this application is to have the right antibiotic. Knowing the right antibiotic in the right time, in the right dose for the right patients, I think it makes a huge impact.
The ECHO model is another way that we're using existing technology, something that's as simple as a webcam, as a way to teach laboratorians how can we better use the microscopes and the equipment that they have to bolster their training so that we can better detect antibiotic-resistant bacteria. Because we won't be able to do anything about the bacteria if we don't know it's there.
By using virtual connectivity, 100, if not 150 participants can connect in at any one given time. We'll create a safe haven for the participants where they're able to come in on a peer-to-peer level, where they feel free to ask questions amongst themselves, to know how to find where the problem was and correct it, so that the next time it doesn't happen again.
What CDC has recognized is that technology is really critical, but what's also really important is having that human interaction, having that mentorship and that training. We were called to assist this really large public hospital because they were seeing high rates of resistant bacteria. We were able to identify what are the major gaps that could be addressed, and importantly, how can we make those changes last over a long period of time.
We focused at 3 areas. One area was safe preparation of medication. The other part we looked at was to have They expect in infection control visiting our unit regularly to assist that IPC nurse in terms of training and supervising. But to me, even much more important is the pharmacist is monitoring medication errors, checking as to the usage of antibiotics.
The role of a clinical pharmacist is highly important to look after our antibiotics, to prescribe correctly, to control antibiotic usage in the hospital. And our goal is that no mother would take her baby home as a corpse from this unit.
Because these antibiotic-resistant bacteria are actually spreading from one person to another person, to communities, and even across borders, we all have a role to play because we all have a stake in the outcome. We really need more commitments and we really need more action. Whether you're the head of a country, the head of a hospital, or even just the head of a household, I think there are a lot of things that you can do together to effectively impact this epidemic.
Antimicrobial resistance is one of the most serious threats globally for public health.
Everybody out there needs to be concerned about this issue.
This is a One Health issue. One Health is the idea that humans, animals, and the environment are all connected to each other. We're within the environment every day. We all interact with each other. We go home and interact with our pets. We're eating food from the animals that are being produced on the farm.
Antimicrobial resistant infections can spread between people and animals.
That to us is exactly why it's important that we work with stakeholders and partners across the pet care community on antimicrobial resistance.
We all need to move the needle forward together through collaborations. That's why our partnerships are so important.
We at PJAC are proud to work with the Centers for Disease Control on all aspects of the pet care community, from breeders and distributors of animals to food and product manufacturers, service providers, and retailers. We look at the sanitation that's used to keep clean environments. We look at transportation protocols, and we also make sure that people working with animals take steps to prevent the spread of potentially resistant diseases before they even enter into the equation, to minimize the risk of antimicrobial resistance developing.
Petco works hand in hand with the CDC, both to make sure that we have strong policies to prevent antimicrobial resistance, but also to ensure we have the right education around that relationship between pets and people. Not only do we not sell any antibiotics over the counter, we also do not allow any prophylactic use, both in our stores or from animals that are coming from any sort of vendor. We put those into place not only because of concerns for our own animal health in our stores and from the supply chain, but making sure that as a company we are being as proactive as possible to protect human health and public health, because we can never forget that these are going to be folks' pets living in the house with their family, and we want everybody in that entire family very healthy.
We all live in one world together. What we do impacts the animals around us. What the animals around us do impact us.
If you make great strides, for instance, on the human side in healthcare, if those same strides aren't made on the animal side, then it's going to set us back.
The biggest strides we're going to make is the entire industry coming together to address these issues so that pets can continue to be an important part of our lives and enrich everything that we do.